Everybody, this is the second video where I take questions from past practice quizzes for introductory or general chemistry, and I just answer them and simultaneously explain what's happened. So you have a question here. It says a teaspoon of sugar completely dissolved. So it is dissolved in water completely. This is an example of what? Whether it's homogeneous or heterogeneous. It is homogeneous. Okay, so when you're studying general chemistry or introductory chemistry, you would have come across different matter and substances. So just a quick touch on that. So if you take matter, so the unit of matter is an atom. Okay, unit of life is a cell. Atom is smaller than a cell. So the matter could be divided into substance, and the other one is a mixture. So substance could be a pure element. What it means is it's any compound from the periodic table, right? Okay, it could be sodium or metal, something like that. Or it could be a compound. Compound is something that is combined of two or more metals, two or more elements or atoms, two or more different ones. So two or more elements is better to use, two or more atoms, different elements. Then you get a compound. So like carbon dioxide, it's a compound. Is it a substance? Yes. It is pure? No, because it's combined. So you go for that. All right, so when it's a mixture, we'll have homogeneous, or heterogeneous. That means in the mixture, if you see a separation, solid, liquid, gas, that is a hetero. If you don't see any separation, that's homogeneous. So sugar and water is a homogeneous mixture. Our question here, asking which one of the following pure substance is an element. We just now talked about it. So it's the examples given here are the element water. We know that's a compound. CH4, that is a compound. Zinc, well, that's an element, right? So, and then they have given CaCl2. So all the ones I have underlined are compounds, which is a combination of two or more atoms of different elements. Zinc is just one element, so that would be the answer. Okay. Now here they're talking about temperature conversion. So it's if a temperature is 11 degrees centigrade, and then what's the temperature in Fahrenheit? Okay. So you have to know the formula so that it is better to remember the conversion formula from Fahrenheit centigrade. So I said Fahrenheit, to get the answer in Fahrenheit, centigrades, you 98 centigrades plus 32. Why it is 9/8? Sorry, 9/5. Sorry, 9/5 coming because there's a range here. So centigrades are from 0 to 100, and Fahrenheit goes from 32 to 212. So there are 100. Here we have we have 180. Okay, so 180 to 100 ratio is 5 to 9. That's why it's here. Why 32? Because this starts from 0 and Fahrenheit starts from this Fahrenheit. That's from 32. So you have to add to start with after you get these divisions right. So this is the formula. You can just remember this, or then again bring the readjust it to give it in centigrades. It's easier just to remember one and adjust it, but I will write this one 5, 9. So you can see if I bring this 32 to the other side, minus 32, then this 9 by 5 change 5 by 9. That's right. So the question is 11 degree centigrade. When I put this formula, what happens? So when you do that, I get the answer here as, that's the answer. Yeah, 51.852. Okay, right. So it's important to remember one of these formulas. Then I have another question here. It's about, okay, 77 Kelvin. What is the temperature in Celsius, centigrades? Okay, so when you're converting centigrades, so remember one formula at least, Kelvin minus 273. Why is that? Kelvin starts from 273 and goes to 373. 0 is the absolute temperature, absolute 0. The equivalent of that centigrades is, that is 0 and goes to 100. So you can see the difference here is 273 and that's 100. Okay, so when you're changing, all you do is you, from Kelvin you take away 273, 50 centigrades you add, but because the starting point 0 that 273, right? So if I have 77 Kelvin here, so centigrade would be 77 minus 273, 196. They're asking 1 cup of kidney beans, it has 15 grams of protein, 1 gram of fat, and 42 grams of carbohydrates. Okay, so they have given the calorie values separately. So energy is measured in calories in the US customary, but joules in the SI units, but here they have given calories. Okay. So for proteins, I'll put P here. It is 4 calories per gram. For fat, it is 9 calories per gram. I don't know how accurate these values are, so I'm just doing this question. Okay. So then for carbohydrates, it is 4 calories per gram. So here it's protein and carbohydrates, they have given the same thing. So if you consume 1 gram of carbohydrates, you get 4 calories. If you consume 1 gram of fat, you get 9 calories. If you consume 1 gram of protein, you get 4 calories. So they're asking if a cup of beans, and they have analyzed this and found out 15 grams of protein, 1 gram of fat, 42 grams of carbohydrate. The question is, how many calories does this serving contain? 1 cup, how many calories are there? This is actually, you don't have to know chemistry or biology or anything. You can just do it mathematical, okay? Because let's take proteins. 1 gram gives 4 calories, so 15. So 15 should give 4 times 15, right? So this is grams, that is calorie. So that's the 4 calories per gram. So therefore the answer should be 16 calories. Okay, the same thing with fat. We have 1 gram times 9 grams per, sorry, 9 calories per gram. So I get the answer That's 9 calories. Then when it comes to carbohydrate, I have, it's 4 calories, but I have 42 grams. 42 grams times 4 calories per gram. That's again 4 times, so 68. So if I add all those things, I get about 237. But the answers given is here 240. So you go for the closest one, 240. Okay. So you can see it's just mathematics. It's not even chemistry questions, but the knowledge and understanding is important for that to answer that question. The states of matter. Okay, so I think I did a question in the previous video. The states of matter in which the particles are very apart, far apart. I said the solid is completely well packed. Liquid is not that so much, but gas would have particles that are very far apart. So the answer is given here: solid, liquid, gas. The correct answer would be gas, because it has particles, atoms, farther apart, the gas. Okay. Okay, so this is a question from Scientific Method. They're saying, you notice your car has a flat tire. In the scientific method, what would you call it? Is it a hypothesis? Is it an experiment? Is it an observation or a theory? So if you notice your car has a flat tire, well, it's an observation, isn't it? So why you have a flat tire is what you have to find out. Okay, how you got a flat tire, but flat tire is an observation. Now, all right, another one from Scientific Method. They say, when you observe that an object has a rotten odor, that is what type of observation? So observation, or whatever the work we do, we can collect data. So is it qualitative? They're asking. When in observation you find an apple, an object has a rotten odor, right? Bad smell. So it is it's qualitative, because there's no number, there's no magnitude. It's qualitative. It is not quantitative, it is qualitative. Okay, which one of the following is a length measurement in the metric system? So they give a range of, because these are practice questions which you're doing. So if which one of the following is a length measurement in the SI unit? In the SI units, length is measured. The SI unit for the length is meters. So anything that has a meter has to be the one. They have given millimeters, they have given deciliters, and they have given centigrade, and they have given kilograms. So which one? It's millimeters, because for the length it has to have the m meter. Asking which unit below is the largest. They have given certain units, SI units, grams, microgram, nanogram, and milligram. Largest is grams. That's why I told you that you must remember that table. Okay. So if you're going to order a gram, then milligram, then microgram, then nanogram. That's the order. So 1, 2, 3, 4. That's the order. They're not asking the order, but it's gram. Okay, these are not that difficult. Then SI unit for mass. I knew there will be a question like this is a SI unit for mass, because for length it is meter, For volume, it is liter. It's right in the middle. But when it comes to mass, it is kilograms. It's not grams. It's not grams, remember that. The normally measurement of SI unit is done by grams, but the SI unit one is kilograms. That's the one we goes. Okay. What is the correct metric relationship between centimeters and meters? So they're asking what is the relationship between centimeters and meters. Okay, so out of the things given, because we need 100 centimeters to 1 meter. That is where you have to remember. So they have given a relationship like this, 0.01 meter. They have not given this one. Why? Because they are giving for 1 centimeter, what would it be? It should be 0.01 is the correct answer. That is because it's 1 over 100, or it's same as 10 to the negative 2, which is same as 0.01. Okay. Why is it? Because 100 centimeters, 1 meter. So 100 centimeter into 1 meter. To make it 100, we divide both sides by 100. Then you get 1 centimeter equals 1 over 100. That's the same thing. So yeah, all things 0.1. That's how we get it. Okay. In a general chemistry or introductory chemistry question, you will be given a value and be asked to convert it to in scientific terms, or just keep it as a number. So you are given a number here, 0.00455 grams. You have to exponential notation. Okay. So when you're doing that, always the questions would come where you have to give a negative one. So those are the common ones, because if you're given a number like 4.020 to convert it to that, it is 5.0 times 10 to the power 3, because 1, 2, 3, right? But this one, there's a negative. So always you will be given, not always, mostly, they try to give a difficult one, right? This is out of the norm, not like this. So always you put a decimal just after the first number, and then you write the rest. But if you want to go for the original one, 1, 2, 3, you have to go back. So 10 to the negative. And you're going back to the left, the decimal. You take back to the left from the one written. Then you put that this number of places you go back. Right? So that's the answer. All right. So since I'm going to end this short video, and I'll call this video 2, and I'll do another paper, some practice question, and then I will go through these answers. Okay, I hope you enjoy this video.